the variance has some problems. It has some issues. In fact, it has one major issue and one more minor issue. Let me make some space and talk about those. Okay, so basically, we squared each deviation. Why did we do that? We did that to avoid the negatives canceling with the positive. But when you square numbers, what happens to them? Well, take any one of our numbers, like let's say we had a deviation of minus 10. If you square that, so if this was a deviation, when I find my squared deviation, actually let me do that here where I've got a bit more space. If I had a deviation of negative 10, and then I square that deviation, negative 10 times negative 10 is positive 100. Not only do I take it from being a negative, which I didn't like, to being a positive, which worked out well, but I also take the number 10 and that gets turned into 100. Deviations are inflated. They are artificially increased in size. So the squaring that we went through in order to solve our negative canceling with positive problem created another problem. It inflated the size of the deviations. So let's go back up for a moment. Sorry, I keep flying around here on you. Have a look at our variances. I'm going to clean this up a little bit here. Sorry, bear with me for a second. So our average square deviation, I'm just going to call it the variance, and we had our variance for our two groups. So actually, let's just use the symbol. For company A, the variance we found here to be 200. And the variance for company B we found to be a 2. Okay, so that tells us that company A has more variation, which is true. But what does the 200 mean? 200 what? Well, think about what we were measuring. We were talking about people's salaries. There's not a variation of $200,000 in salary. We don't see that. Instead, what the 200 actually means is there is, on average, remember this is the average squared deviation. So on average, the squared difference between a person's salary and the typical salary, so the average was equals to 50. On average, the squared distance from there to there is 200. Well, what does that mean? That does not sound like an easy thing to wrap your head around. It's much easier to think of 70 as being 20 away from 50, so deviations make sense. A deviation of 20 just means you are 20 away from the average. A deviation of negative 10 means that you're 10 below the average. A squared deviation, that's a complicated thing to try and imagine. So the variance works mathematically, but it leaves us not really understanding what our answers are talking about. 2? What does the 2 mean? Well, the 2 means that the average squared size of these numbers is a 2. Well, the average squared size of these numbers is a 2. That's, again, not very helpful. So we squared our numbers to get rid of the negatives, but then the numbers became too big. So what we're going to do is we're going to unsquare these results. How do you unsquare a result? Well, if you want to unsquare a result, you do this. You take the square root of your result. So the square root of the variance would be the square root of 200, and that is 14.14. Over here, the square root of this, so if I wanted to take the square root, so I'm just going to write it without the squared sign because it's not going to be squared anymore. The square root of the variance is the square root of 2, and that's equals to 1.414. Now, we simply square rooted things to bring these numbers down in size. Notice that the 2 reduced down to 1.414. The 200 reduced all the way down to 14, or a little bit more than 14. What does that mean? Well, because we took our deviations here and then we squared them, we then square rooted to get back. So that's like saying that the average size of these numbers, the average of our deviations, is about 14, which makes sense. Look at these numbers. The numbers are 0, 10, 20, 10, 20. So these numbers, on average, are somewhere between 0 and 20. There's a couple of 10s, so they're somewhere a little bit towards the 10 and 20. Excuse me. So the average size of these numbers is around 14. The average size of these numbers isn't going to be around 14. It's going to be somewhere between 0 and 2. It's about 1.4. This final step of taking the square root helps us to give an answer that makes sense in terms of what it was we were talking about in the first place. This is, we stick with this step, we keep this throughout the course. Taking the square root like this is called the standard deviation. And very simply, the standard deviation is the square root of the variance. So let me make a bit of space and show that. The standard, actually I'll write it out. Standard deviation is equals to the root of the variance. We write the standard deviation as just being sigma, and it's the root of the variance, which is written as sigma squared. The standard deviation has that added benefit that we get a measure of variation that is going to be big when there's lots of variation, small when there's not so much variation. Notice this is a 14, this is a 1.4. Also, the numbers themselves make sense in the context that we're talking about. Remember, company A here had an average, let's do this in blue. It had an average salary equals to 50,000. Now, that's easy to understand. If somebody said this company pays its workers on average 50,000, you know exactly what they're talking about. The standard deviation now is something that we can add to that. When I add a 14.14 and so on, this is like saying, on average, people make within, they deviate from 50 by about 14. So it's like saying, people make $50,000, give or take $14,000. Over here at company B, the average is 50,000, but now it's give or take $1.4 thousand roughly. I know that there's more decimals here, but basically this is like saying that you can expect to be within $1.4 thousand of that 50 grand. That's what a standard deviation does. There's a bunch of mathematical steps in order to get to the point where we have a meaningful, understandable measure of variation.